Oh, so let's take a look at views. Oh, did I record? Yeah. So if you remember early on when we started talking about databases in general, we mentioned the fact that most modern databases allow you to store the data in a particular format, right, in a particular structure, presumably a very normalized data structure, where you split it up into multiple tables, but that oftentimes that was inconvenient because it was usually not the way you wanted to consume the data. Right? You split up the data in the first place to avoid redundancy and avoid the risk of inconsistency, right? Based on the different queries that we wanted to do against that database. So oftentimes the way we store the database is not necessarily the way we want to consume it, right? And depending on who the audience is that wants to consume the data, it might be more convenient to display it one way or display it some other way. And different folks might want to read it differently. We might have split the student information across students and sections and enrollments and courses. But if you're the registrar's office, you don't care about normalization. Perhaps you want to view the grades and the student and the course, right, all as a single query, right, as one single table. And so oftentimes we want to have the capability of both making sure that we're storing it normalized, but being able to display it denormalized, right, in a way that is more convenient. Right? And certainly we can do that by applying joins, right, and select statements. And there might be some select statements that over time we realize it's a very, very convenient select statements, right? This is a very, very useful select statement that is grabbing from this table and that other table. It's joining them. It has this really cool predicate. It's filtering, it's ordering, and it's grouping, and it's doing all these kinds of things, right? And would love to be able to reuse it as as if it were a real table, right? And like to be able to query over it. So that's exactly what views allow us to do. Allows us to create these pseudo, these virtual tables, so that we can treat a temporary query like a select statement that we might find useful, and then we can reuse it over and over as if it were an actual table. Right? What this allows us to do is to maintain the original data stored in a normalized fashion, right, without the risk of inconsistency, right? But then also be able to retrieve it and read it and consume it in a convenient fashion. So to create views, we use the keyword create view and then the name of the view, and then associate it or link it to a select statement that we might have identified as very useful for our operations. And we've actually been using this idea throughout, right? Because what this does is that it creates something that behaves and looks just like a table, even though it's not a real table. It's if you open it up, it would list it on the left-hand side just as another table. And if you click it, it'll show columns and rows and whatnot. But it's just basically the result of having the latest execution on this select statement. Right? If the values of the original tables change, the view also changes. The view always shows the very latest of the result of having executed the select statement. Right? So if any of the constituent tables changes, right, the values of the view also change. Right? Now this is great. And if you're doing lots of read operations, that's really good. Now, if the data changes, if the data doesn't change much, right? Notice that the select statement has its costs, right? That every time you view, every time you're looking at the content of that view, you are re-executing the select statement. which is fairly costly, especially if it's a very popular view that everybody's opening it up, right? It's re-executing this. If it's multiple tables, it's joining a whole bunch of tables, right? It's walking through all the records of all those tables to fulfill that join. So this could become very, very expensive, right? So there are other versions of views which are if the data doesn't change much, right? We might consider using other versions called materialized views, right? What they do is that they execute the select statements only once, well, at least once at the beginning, and then they cache those results, right? They cache the results so that every time you look at them, they're not re-executing the select statement to recreate whatever the views was, right? It only re-executes the select statements when it identifies that any of the underlying data of the constituent tables has changed. So if there's a new insert, if there's a new update, if there's a delete on any of the tables from where the view is created, then it will know to reselect, right, and rejoin and rebuild the view and recache it, right, so that it can optimize the queries. Okay. So let's take a couple examples on how we might use views. Okay. So here we have a view that we call current product list, right? That is basically taking a look at a subset of the products in the products table. Right? So we have the products table, and we want to just filter and look at only the products that haven't been discontinued, right? And we call that the current product list, right? Where there might be a lot of legacy products that we're keeping track of them only for historic purposes and for auditing purposes, but it's just cumbersome. Maybe we always coming up with lots of new products, right? But we keep track. Maybe 75% of our products is stale. We're not using it anymore. We only have a subset, 25%. So this is a very, very convenient view that would filter and always show me only the 25% of those products that are indeed current, right? And then what's convenient is that now you can use that view as if it were any other table, right? As if it were any other. You can use it in joins. Anywhere where you could have used a table, you can now use a view. So for instance, you can say select star from current product list, right? You typically only use tables here, but you can use also tables, and also you can use views. And you can join them. You can join a view with another view where one field of one view is equal to the field from another view, right? Or tables and views, you can mix and match, which is pretty cool. So these are all virtual. These are not real tables, right? These are intermediate results of having executed some select statement, right? That you can want to treat it as a view. Here's another one. And we're creating another one of products above average price. So here we're selecting fields, product name, and unit price. And from products, where here, notice that we're aggregating the product table, right? We're taking it as an entire set, right? One single big group, and over that we're aggregating the average unit price. Right? So once we have that, this returns a single value. This returns a single value, which we are then using it in a predicate. Right? Unit price is greater than that aggregate value. And this returns only those products whose unit price is greater than the unit price of the whole product, all the products, right? And then we're wrapping this entire nested select statements with aggregations and whatnot, and we are aggregating into. We are storing the results. We're giving it a name: products above average price. Right, so that generates a new view that we could treat yet as another table, as if it were a table, but it's not. Here's another one. Creating a view of category sales for 1997, where we have a select statement that is aggregating the category names. That it's grouping all the category names, and then it aggregates the product sales and gives it a name, category sales. From product sales from 1997. Product sales for 1997. Do we have that? I don't believe we created that view. Yeah, so presumably this this product sales for 1997 would be something like this one, right? Where product sales for 1997, where the sales year would be equal to 1997, would create one view, and then that view can then be used as another table, right, to create another view. So you could build a view on top of other views. So it would be nested select statements, one inside of the other. We've been using this all along, right? When we use this notation, Q1 is equal to a select statement, and then we use Q1 to feed it into another select statement. Right, so we've been using this all along, but here's the syntax that we would use. Right, it would be create view Q1, and then the select statement, and then create view Q2, right, where there's a select statement that uses Q1. Right, so you can create these nested subqueries. So views are just a very very convenient way of creating subqueries. So here's another one where we're saying from category sales for 1997, only return the one that the category name is equal to beverages. Okay. Right, yeah, we've been doing this all along, right? We select Q65, select S name, S graduation year, whatnot. It was the same thing as saying create view Q65 as, and then the student. Reusing the queries, right? Views can be used just like tables. So wherever a table could be used, you can use a view. So here's Q65 is a view we just created earlier, where the graduation year is 2004, is equivalent of doing that, like a nested loop, a nested query inside of each other. I think that was the same thing. So this is what we meant by external schemas, right? That when we meant earlier, when we began the course, we said that databases typically provide multiple ways of representing data. Certainly the way you would store it internally would be in this you would store it in a normalized fashion, right? But then you might want to consume it in a denormalized fashion, right? Where we join all these things that we originally had broken them apart. We broke them apart to avoid redundancy, but we might want to join them again because it's a more convenient way of consuming the data. You would never actually denormalize, only for the purpose of presentation, because it's convenient to display it in some fashion, right? You would just always keep it under in a normalized fashion and only provide a view or a materialized view for display purposes. So let's look at examples using the university database that we've been using so far, where we have maybe the student info that we might want to join several fields from multiple tables. Here, student info has the student ID, student name, the GPA, the number of courses passed. So that looks like it's an aggregation, right? Some computation. The number of courses failed. That also looks like an aggregation. Student courses, year offer, title, professor grade. So that looks like we're grabbing a couple things from the course. Some things are being grabbed from the enrollment maybe or the section. And grade from the grade looks like we're grabbing that from the enrollment. Title, that looks like we're grabbing from the course. So we're aggregating several things from several places. So we would never actually create these tables, right? Instead, we say, well, we've gone through the process of normalizing, and we can certainly denormalize it for you in a view. We can create a view called student courses that joins three different tables. Right, it goes off to an enrollment table, the section table, and the course table, joining them right together, right, so that we navigate from one to the other, and we retrieve the fields for each one that we need, like the student ID, the year offered, the title, course title, the section professor, and the enrollment grade. Right? So this combines all those values from a convenient representation, and it hides also the details on how is that the data is actually stored and how is it actually being represented. And now one of the challenges that we introduced by using views is that they're not real tables, right? So you can't really do everything you could do with a table. Right? Certainly, you can use them for read purposes when you're retrieving data, right? Because nevertheless, at the end, they're just select statements, right? That retrieve and read the data. But unlike tables, you cannot update them, right? Because they don't exist. These tables don't actually exist, right? Certainly, a real table, you can identify a particular record, a particular field, and update that field. In a view, that record that you might want to update, it's actually a combination of multiple fields that you might have gotten from different tables. So what would it mean to update a record in a view? Right? It would mean that I would need to somehow propagate the changes in the view, propagate them into the original tables where I got the data from. Right? If the mapping between a record in the view can be uniquely mapped to the original field, right, for the particular record from where it was grabbed, then it might be doable, right? Because there's no inconsistency. There's no way to interpret how that particular field was calculated, right? Where you got it from. It says that value, you got it from this field in this other record, right? So if I update this field, then I can propagate that change to the original record, right? But if it's so single table views, so maybe a view that only uses a single table, then we could consider that the original table could be updated and update up to the view, unless it's grouped, right? Because if it's grouped, what would you do? Because the record that you're looking at is actually an aggregation of multiple records. And so changing a value on a value that was calculated, how would that propagate to the hundreds, thousands of records that were originally collapsed into a single view record, right? That would make no sense. Right? So if you try to change the average of the class, what does that mean? You make it a curve that then you bring everybody's grade up to match that average. What would it mean to the original records? And especially if it's multi-tables where you have joined values from multiple ones, right? Where you're doing the primary keys foreign key, right? That becomes complicated, right? So say you have a one record, right? That grab students from the student table and maybe departments from the department table. What would it mean if you delete that record from the view? What does that mean? Does it propagate down to removing the original records from the original tables? Is that what it means? That you want to remove the original student record and you want to remove the department record? Is that what you're trying to do? Or would it mean that you remove one but you make null the other pointer? Is that what you mean? So let's consider this view where we're joining two tables, right? We're joining the student table and we're joining it with the department table where the major ID matches the department ID, right? And so it's a convenient view that somebody wanted to have an aggregate wanted to bring together both data for the student and the department, and we gave it a convenient name, student major view. So what would it mean to make a delete on this, right? Or what would it mean to make a change in the art here? Right? If I want to change this department name, does it mean that I'm changing the name of the department? Or does it mean that Joe is no longer in the art department and it's in somebody else, in some other department? What does it mean? Right? So since there's no one specific way, unambiguous way to interpret what you mean, right? Then we typically disallow those changes. Okay. So for instance, would it mean that if we delete Sue from the student, right? So if we want to delete Sue Math, so here's Sue Math, right? So there might be multiple interpretations. Does it mean that we want to delete Sue from the student table? Is that what you mean? Or do you mean that we want to remove the math department? Probably not. Okay. Or did you mean that this relationship doesn't exist anymore? Right, that Sue is no longer in the math department. Sue is actually in some other department. Right? Maybe that's what we mean. So since it's ambiguous, right, we typically disallow this. What we would typically do. Oh, here's another one. Right, say that Joe is already in art, and now into this view, right? We now want to insert into this view. What does that mean? That if I now insert Joe drama, does that mean that Joe is no longer in art? Instead, they are in drama? Is that what it means? Or that now we allow students to have multiple enrollments? Is that what we mean? So again, the intent is ambiguous, right? It's not clear how would we interpret this. So ideally, what we do instead is that we use a programmatic mechanism such as store procedures that would allow you to specifically say, what do you mean, right? That to do this, and we would run a store procedure that would trigger this, so that if we do insert into the view, that can be used as a trigger to execute a function, right? A store procedure to actually do these things. Unenroll Joe from art, and then instead enroll them into drama, right? And we would trigger these things and execute them in a store procedure, and that's where we're going to look at next.